On this first question, let f of x equals 3 halves x to the 3 halves power and g of x equals 1 half times x to the 1 half power. They're both power functions. Find f divided by g of x and state the domain. Okay, so let's first find f divided by g of x. And so I just follow exactly what it says. I put f on top, 3 halves x to the 3 halves power, divided by 1 half times x to the 1 half power. Now I just have to simplify this. Okay, so first the fraction. It's a complex fraction, so I'm going to multiply the top and the bottom by 2, and that's going to get rid of these 2's here. And I'm just left with 3 over 1, which is just 3. And now I'm dividing the x's, and whenever I'm dividing with like bases, I subtract the exponents. So 3 halves minus 1 half, 3 halves minus 1 half is 2 halves. 2 halves is the same thing as just 1. So this is equal to 3x. Okay, now the domain, remember with these kind of combinations, function combinations, the domain is in the overlap. If you're going to draw a Venn diagram, it's this part where they overlap. So we need to find the domain of each of these functions. Okay, so since we're taking roots, an even root, I know that it can't be negative. And that's it. It's just that x has to be greater than or equal to 0. X is greater than or equal to 0. So the domain on this one, since they're both the same, should be x is greater than or equal to 0. But wait a minute. We can't have the denominator here equal to 0. And where is the denominator equal to 0? Well, the square root of 0 times a half is 0. So actually, the domain is x is greater than 0. That's pretty tricky, huh? Okay, let's look at another question. Same exact functions. This time we're going to find f composed with g of x, a function composition. And remember, the one that's closest to x is the one that's going to go in for x in the exterior function. So we're going to take all of g of x, I'm going to stick it in for x in f of x. So f composed, or fog, of x is equal to, on the outside I have 3 halves, and in the place of this x right here, we're going to put 1 half x to the 1 half power, and then all of this raised to the 3 halves power. Now let's just clean this up just a little bit. And whenever we have a power raised to a power, we know we're supposed to multiply the powers together. So I have 3 halves on the outside times 1 half to the 3 halves power. And then x to the 1 half times 3 halves is 3/4. Now, here you can leave your answer just like that. This part right here can be simplified a little bit, but for right now, I'm not worried about you simplifying it. I just want this actual answer right here. Now we need to state the domain. Now, for function composition, the domain is a little bit trickier. The domain, well, domain means what you get to stick in for x. And what we're sticking in for x is g of x. So the domain should be the domain of g of x as long as its range is in the domain of f of x. Right? Because we're going to take our answer, or we're going to take something for g of x, stick it in, whatever we get as an answer, which is the range, we're going to stick that answer in for f of x. That's what function composition means. So we need to find the domain and the range of g of x. So for g of x, we have already stated that the domain is x is greater than or equal to 0 because it's an even root. And its range, well, think of this. This is just 1 half times the square root of x. If you were to graph that thing, put a tiny, tiny little graph, it's just this thing. Right? It's half of a sideways parabola. It's the top half of it, which is y is greater than or equal to 0. Okay, now for f of x. F of x, we need its domain. Since this is also an even root, we already stated that the domain is x is greater than or equal to 0. So the domain of the composition should be the domain of the interior function, which is g of x, as long as its range is completely contained within this. Since all positive numbers in 0 is exactly equal to all positive numbers in 0, then we're good to go. And what I put in the box right there, this is the domain. Okay, so now let's look at another question. This one is a decomposition. So I have h of x equaling the square root of x minus 5 plus 2, and I want to find two functions so that whenever I do the composition, I put g of x inside of f of x, I get h of x. Okay, so look inside of the square root. Inside the square root, I have a little linear function. Let's let that equal g of x. X minus 5. Now, if I take this and I stick it into f of x, what does f of x have to be so that I get the original function h of x? F of x needs to be the square root of x plus 2. Now, if I take x minus 5 and I stick it in for x right there, I get the original function h of x. So there are my two functions that I just decomposed h into. Okay, let f of x and g of x be defined by these two graphs, and find each of these compositions, combinations, whatever. So f plus g of 0. So I want to find f of 0 plus g of 0. F of 0 is negative 1. G of 0 is 0. So negative 1 plus 0 equals negative 1. Okay, on B, I'm finding f of 0, and I'm dividing it by g of 0. Well, I already found those two values on part A, so this is negative 1 divided by 0. Divided by 0, oops, undefined. Okay, and then finally, I'm finding g of 0, and I'm going to put it in and find f of that answer. So g of 0 we already found was 0, so I'm going to put that in for f. And f of 0 I already found is negative 1. And that one's done. Okay, final question. We're going to find a difference quotient for f of x equals 2x squared minus 3x plus 5. So remember, my suggestion is to find f of x plus h separately, this part of the difference quotient. So everywhere there's an x, we're going to put x plus h in its place. Minus 3 times x plus h plus 5. And now let's simplify. So 2, I square out this x plus h, I get x squared plus 2xh plus h squared. Minus 3 times, well, no, I could go ahead and distribute that. 3x minus, don't forget the minus sign on the 3h, plus 5. And now let's distribute here. I get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Now I have to subtract out the original function, so minus 2x squared minus a negative makes plus 3x, and then plus, or minus a negative 5. Okay, and this is the difference quotient, so now I'm dividing it by h. And now let's cancel out. Remember, if you do this correctly with polynomial equations, the original function always cancels out, and I'm left with 4xh plus 2h squared minus 3h, all divided by h. And this h divides into all of the things up top, so I have 4x plus 2h minus 3 and that's the difference quotient. The end. Good luck on your quiz.